Good morning, everyone, and welcome to the Wheat and Small Grains Crop Hour this week. And today is our third day or the last day of the week. And today we'll have two presentations. First half of the hour, Dr. Chris Graham will discuss winter wheat management and some of the winter kill and surviving and what happens during different growing conditions. And in the second half of the hour, which will start at 10:30 or so, and I'll be discussing oats agronomy and some of the nutrient management in oats. I should probably give my brief introduction here. So I've been the host or the moderator for this week. My name is David Karki. I'm an agronomy field specialist with SDSU Extension, and I'm based out of Watertown, South Dakota. And I do a lot of all the major crops and cover crops also lately. And like I said, I'll be discussing oats agronomy in the second half of the hour. So before I give my microphone, lack of better words, to Chris. There are a couple of things I want to mention. Down on the bottom of your screen, you'll see two functions. One is Q&A and other one is chat. Both functions have this little comment box icon on it. Throughout the presentation, anytime if you have any questions or comments or problem with the system or whatever you have, please feel free to type that in, and then us and our EdTech team, SDSU Extension's EdTech team, will be looking at it throughout the hour. So now, without further ado, Dr. Graham will be talking about wheat.
Okay, David, how does that look?
Looks good.
Okay, great. Well, thank you very much. As David mentioned, my name is Chris Graham, and I'm going to be talking specifically about winter kill in winter wheat. And just as a brief background, I'm an associate professor in the plant science department and also the manager of the West River Research Farm out near Sturgis. And so I'm based in Rapid City. And so a lot of my bias, I guess, is towards the western side of the state, and that's where a lot of my information is coming from. And so certainly plenty of wheat is grown in the eastern side of the state as well. And so I think there's still a lot of relevance for the entire state, but certainly different conditions in general. So only have about 30 minutes. I think I have many more slides than I do time. So I'll go through just some of the physiology of winter kill and maybe related to some of our current conditions. And then if there's time, I'll try to get to some of the recrop options. So I wanted to start with this chart. It basically just shows the theoretical temperatures at which freeze injury would be expected to the wheat at different growth stages. And these were, like I said, this is theoretical, is determined after a 2-hour exposure at each of these temperatures. And, so in general, winter hardiness or, cold tolerance, kind of synonymous. It's a physiological process that's triggered within the plant by gradually cooling temperatures. And so this tends to start shortly after germination in the fall in winter wheat. And sufficiently developed wheat seedling begins cold acclimation when temperatures at the crown level, so the crown depth in the soil. And I'll probably mention that multiple times, but I think that's a really critical distinction. Is when we're talking about temperatures in general, I'm talking about temperatures in the soil where the crown of the plant is, rather than air temperatures. And so this process starts when crown temperatures drops below about 50 degrees. And, as you can see in the early phase here, I think you can see my mouse, the early emergence into that 0 to first leaf is when the plant is most susceptible to cold temperatures in the fall. So during this cold acclimation process, there are a number of things that are going on physiologically within the plant. The first thing generally is that it starts to accumulate carbon sugars down into at the growth point into that crown area. And that's for its growth as it comes out of dormancy later in the spring. The other thing that happens is there are certain genes that are expressed that initiate the production of what we call these antifreeze substances, these proteins. And more or less they work like we call them antifreeze because it's similar to what it happens in the car. Basically, these proteins engulf ice crystals or surround ice crystals to prevent them from coalescing and forming larger, larger ice structures within the plant. And so basically they inhibit the growth of ice within the plant. It generally takes about 4 to 6 weeks at soil temperatures below 50 degrees for the plant to fully cold harden. And, kind of the old rule of thumb is 45 days is the minimum, but it certainly depends on temperatures, how rapidly the temperatures are falling, and, the variety itself. Ideally here you see this minimum or the maximum resistance by, November, sometime late November. The plant is at its maximum resistance when we have our naturally our coldest temperatures throughout the winter. The reverse is true as well on this process. You can see where as it starts to come out of this hardening phase, on this right side of the graph here, the plants begin to unharden. So as temps rise above 40, 45, 50 degrees, these plants start to take off again, and that's when we start our green up in the spring, but it can happen in the winter as well. Okay, so this is a fairly similar slide to the previous, fairly similar graph as the one on the previous slide, but it shows this winter hardening process come from a slightly different angle. Again, the graph shows the minimum survival temperatures here on the y-axis, and then throughout the growing season here on the x-axis. But what it also shows is you have your average in this black line, and then you have a range here in this kind of the gray shaded area. And again, this is sort of prolonged exposure to temperatures at that crown level. One of the things that this is showing is, or it really highlights that there's a significant genetic component here. Multiple planting. So one of the things that we can take from this graph is that planting different varieties or multiple varieties is one strategy to protect against winter frost. But the thing to point out here is that the biggest range in winter hardiness is not so much in this hardening process in the in the late fall, early winter, or even at the depths of winter, but where varieties tend to differ the most is in that unhardening phase, or as temperatures begin to warm. There's a big genetic component to how they respond to warming and freezing conditions. And so this big range here shows how these plants respond at different, at different, from a varietal perspective at different frost damage levels. And so I thought this is just kind of an important graph to show how that varies. So let's see, moving on. This is basically, I've talked a lot about this already, but this is some of the general indicators for freeze injury and winter kill, some of the primary factors. As I mentioned, that prolonged exposure to cold temps, lack of snow cover and stubble, that's obviously a big one. This table is kind of interesting. This is developed from theoretical ranges once again. But what it shows here is snow depth on the left hand side, and then air temperature here on minus 22 degrees, and then minus 44 degrees. And it's showing the depth, the temperature at the crown level based on snow depth and these two temperatures. And you can see As the snow depth increases, it's warmer and warmer, almost 20 degrees difference, 20 Fahrenheit degrees difference with between 1 inch and 5 inches of snow. And the curious thing here, though, is even if you doubled the temperature going from -22 to -44, obviously you have about a 10-degree drop when there's only an inch of snow, but only a 2-degree drop when there's a much thicker layer of snow. So, the take home, it's common sense, but the more snow we have, the more insulation that snow provides. And I'll say, if you drive across the state right now, there's a huge difference from east to west. Pretty good snow cover throughout the eastern part of the state, but as you get farther west, very little snow cover throughout the winter. And as I look out my window, there's a lot of bare ground. And so certainly geographically, this is going to be a bigger concern, I think, for the western wheat growers. Topography makes a difference. Likely it's most severe along the rivers and your bottoms, your low-lying depressions. And then, as I mentioned, the fluctuations coming out of that freeze-thaw period, that's where we tend to see a lot of plant death rather than just extreme cold temperatures. And then late planted, slow developing stands in the fall. I'll talk a little bit more about this, but I think this is a concern for a lot of wheat across the state. Not so much for late planting necessarily, but for drought and slow developing stands. So these are some data from our research farm near Sturgis. This is just actual soil temps. A couple things this graph is showing. First of all, this goes back to about November of this year and just ends just the other day. I think it's the 7th or so of February. Temperature on the y-axis here. This blue graph here is showing the air temperature, average for a 24-hour air temperature. And then these two gray and orange lines show both the soil temps at 2 inches and at 4 inches. And this is a sod cover. We have a bare cover soil temperatures, but it actually doesn't vary as much as you'd think. So I left it out. But really the point here I want to make is that, soils heat and cool a lot slower than the air temperatures do. And then water heats up and cools down a lot slower than soils do. And so, they're not, the soils, as you can see, even in the depths, like we had these below zero for a couple days around Christmas time. And you can see a small dip in soil temperatures, but not like you'd expect where we have, pretty significant negative temperatures. And so by and large, our soils right now are hovering around 30, 32 degrees. So we don't really even have much frost in the ground. As you can see, it's been a fairly mild winter based on the air temps. And so again, my concern this year in terms of winter kill is not so much the extreme cold depths. It's where we've had lack of cover and we've actually not had a lot of frost. And so, you may see a lot of dehardening or unhardening of plants as they move into the spring. Okay, so the obvious question farmers start to ask is, as we get into green up in the spring, is my wheat dead? And so this is kind of in hindsight, but ideally we'd have 2 to 3 tillers with each plant and 2 to 3 leaves going into the winter. That wasn't the case for a lot of the wheat that we saw, at least in our plots. And so that's of concern. As I've said a couple times already, where's the crown at? Don't care so much about the air temperatures. It's the temperatures at the crown. And so planting depth is important here. Ideally, it's an inch and a half below the soil surface. Drought, as I've mentioned, and we'll talk more about later, obviously a concern. Dry soils tend to warm and cool faster than wetter soils, as I mentioned. And so insulation is important, that snow level is important. these pictures here on the right, I put them in. I think they're kind of nice to as demonstration. You can see these two planting dates, one in late October here on the left and one on the right here, where there's much more crown development. And you can see here there's these protrusions coming out. These are called the crown roots, and they tend to grow more laterally. And so they're similar to brace roots in corn, and that's their primary function throughout the growing season is to add stability to the plant. However, in the early growing season, these crown roots, where'd my mouse go? These crown roots are really critical for water uptake for the early growing seedling. As the plant ages, these seminal roots below the seed, you can see these seminal roots grow vertically. So they go down into the soil and they become the primary source of water and nutrients. But as a diagnostic, looking at plants, say going in the fall or even in the early spring, you can pull out these plants and you can see, are these brace roots there? Or do we have only seminal roots? You know, that obviously adds to a weaker crown as it begins to mature. So, you know, one of the things that I think, you know, is again, must be said is that it's not so much, we're not so worried about the, you know, you see the burn in the leaves and you makes people concerned about some of the, you know, if there is winter kill, but it's not so much that that top growth. I think it's more important to look at that root structure. If plants are killed outright by the cold temperatures, they're not going to grow or green up in the spring. But if they're only damaged, say your crown roots or some of your seminal roots are just damaged, it might take the plants a little bit of some time into the spring before they actually die off. In some cases, you know, they'll green up and then they'll go backwards. And this happens because for some period in that early green up phase, they do have enough water, enough nutrients to start to grow. But then as any injury, if it's drought injury or if it's you know, cold injury, it damages that vascular system. So any remaining nutrients after that initial store is used up can't be delivered to the plant, and so it slowly dies off, or else, you know, it also becomes susceptible to root diseases and things. So it dies off. And I guess the point there is take your time in assessing these fields. It takes a while for them, and you get that later die off, which can be problematic. Just a couple more pictures showing on the right hand side, just a stronger crown root system there. Again, that is right here, right where it meets the root system, versus some weaker, where you'd rather see more of those horizontal brace roots. You don't see that much here, just the seminal roots. And so rather see a more developed crown going into the dormancy period. If you really want to test, there is this bag test. Many people have already heard about this before. It's a pretty simple test. Essentially, you can go and dig out some representative plants from various parts of fields, thaw the samples, and then wash them to remove any soil and debris from the roots. Typically, you cut about 1.5 inches up above the crown, and then slightly below those brace roots. And then put them in some sort of Ziploc bag, inflate the bag, and then close it so that it has some air. Put it in a well-lit room, not directly in sunlight, so it doesn't dry out. And then you can watch the growth. It'll start to grow within a couple days. After about 6 days, if you don't see any growth, the plants are dead. And so it's a very simple test. Other times, people will just take the plants with the root system and just plant them in a pot or something and see how they grow. So there's pretty simple ways to determine whether you have some winter kill. So let's see, this, you know, this is just more illustrative of how spotty these things can be throughout fields. And really kind of highlights the necessity to take samples from a really distributed samples design across a field or area. This particular field, on the right-hand side, you can see a much better stand. On the left-hand side, pretty spotty. We actually had a planter malfunction here. So we got this part planted, then the planter broke, and we didn't get back for another 10 or 12 days or so. And had a very cold October and November, and then a really dry winter. And so this is the picture, right, where you can see that split pretty obviously after green up. And so, we counted 10 to 12 plants per square foot with 0 to 2 tillers in a plant on this left-hand side, and then 15 to 20 plants and 2 to 4 tillers. And this just shows these are the tillers from this right-hand side versus the plants from the left-hand side. And so this is where we kind of start to do the math and figure out, is it worth salvaging these areas? Obviously, the right-hand side is pretty promising. If the field looked like the left-hand side, then it's a little bit more guesswork. I didn't put in any sort of tables. There are lots of tables to, certain number of plants per square foot or something. And it varies so much from state to state and from different insurance companies. And so, sometimes they say, well, 15 to 20 to 25 plants per square foot is about a full stand. And then you have some percentage off of that. Some people go as low as 5 plants per square feet to as a minimum for what they'll save. So it really varies quite a bit. I really want to weed into that too much. But yeah, so I think experience will tell you as well based on your planting populations. Okay, so I debated putting this slide in. It is, obviously I realize that insurance is going to be one of the biggest guiding principles for most folks. So let's transition a little bit and say, okay, I'm gonna go ahead and start looking at options for replanting. Wheat stand is terrible. What do we do now? And I think, obviously I'd be remiss if I didn't mention insurance. But with that said, I am certainly not a insurance salesman. And so I don't want to get too deep into this stuff because plans vary quite a bit. But yeah, so the first question I think most people will ask is, well, what does my insurance dictate? What I can and cannot do based on my insurance? And so most plans, for winter wheat will have this automatic replant option where you basically take your loss and or you replant some sort of they'll say, okay, just replant spring wheat into these areas. Depending on how big that area is, maybe it's mixed in with your winter wheat where it's just spotty, or maybe it's larger fields. That certainly depends on your policy. A number of pros and cons with that. Ideally, we don't have to change the rotation. So if you can keep that stand, great. Maybe it rebounds. Maybe you can sneak in some spring wheat, and protein's not going to be an issue, probably. But then you have some maturity differences, and so there are a few things to consider how that works. The winter option is a bit different in that you pay an additional cost to your base policy, and you have complete loss on your wheat. And so typically, now this is I think on a lot of plans, but not all the time, you basically, the winter option gives you it gives you a bit more flexibility in terms of what you can and can't do in the spring. So you can take 100% of your winter wheat loss without insuring newly seeded crop. So you can either fallow it, or you can plant something else and just not insure it. Or you can take 35% up front and insure the second crop. And then what happens is, if the second crop makes it, great, you pick up your extra 65% on your wheat loss, and you go on your way. If the second crop fails, then you can get 100% of that loss of the second crop and 35% from the winter wheat loss. And so I wouldn't even dare to try to get into all the different permutations in terms of losses and yields and stuff. That's well beyond my it's way out of my lane. And so I just wanted to bring it up because I know that it's a pretty large guiding factor for a lot of farmers in terms of what to do next. So just a couple minutes left. I'm just going to tackle a couple things really quickly. If you put the insurance debate aside, what are the other prevailing factors that we're experiencing this year? I already talked about it some, but obviously drought is going to be a complicating factor. This graphic is from the drought monitor. It shows the current drought status across the high plains. As you can see, almost the entire high plains is facing abnormally dry conditions at a minimum, and much of that is in moderate to even exceptional drought as you move farther south. And so obviously a lot of farm ground is going to be entering the spring with some level of soil moisture deficit. The other concern I think that arises in a case like this for a lot of farmers is, what do you do with a winter wheat field that didn't germinate in the fall? And so there's that vernalization process that the winter wheat must go through. So there's a concern. And within that plant, that vernalization process is first sensed within actively dividing cells. And so that implies that the plant is germinated and it's growing. And so a farmer says, okay, well, if my wheat doesn't germinate, will it get enough of that? I said maybe 45 days or so at temperatures below 50 degrees. Will there be enough of that cold period to vernalize? And the problem with that is that the wheat will look like it's doing just fine, and then it doesn't. The vernalization period actually stimulates that conversion from vegetative growth to reproductive growth, and so that doesn't happen until early May. And so a lot of farmers they see that, okay, my wheat doesn't joint, and so now what do I do? It's May, it's too late to plant wheat now. And so you got to start considering other options. And I think that type of scenario, it favors crops that have a longer cropping window, which would maybe allow time to take care of or to take advantage of some early spring rains. This is just the seasonal drought outlook. The good news here, I'm going to gloss over this really quickly, is that it looks like La Nina is breaking, and we might return to more normal spring precipitation. So you can see in this top in the upper plains, this green and the gray areas show a lessening of drought in the forecast. So that's good news. The last thing, maybe I'll just end it right here, David. The last thing I'll say is that I put these 2 bullet points in here, and we talk some about carbon, maybe not enough, but there's always these numbers thrown around. So every 1% organic carbon, every 1% of organic carbon in non-calcareous soils carries an average of an extra inch of water in the topsoil. And that's across all soil texture classes. And so that works out to about 10,000 gallons of additional water for every 1% of soil organic carbon. Actually, if you break it out and you look at calcareous soils like we have out in the West, high pH soils, it's not quite the advantage as in more neutral pHs, but it's about a half inch, so about 5,000 gallons for every 1%. And so really the reason I bring this up is that if you're not building carbon, we're losing it. And carbon losses and gains are in constant flux. And at the end of the day, it's a mass balance between how much carbon is entering the soil and how much is being consumed by microbes or lost by erosion. And with this persistent drought, it's pretty likely that we've been losing soil carbon over the last couple of years. And with that, we've been losing that ability for the soil to hold water. And so I think this carbon issue has to factor pretty strongly in what crops we choose going into the spring if it's not going to be that winter wheat. At our farm, we try to we take that Dakota Lakes model of 65 to 70% high carbon crops in a 4 to 6 year rotation. And so, it depends on where this year falls within your broader rotation. But I think stacking broadleaves, for example, could be potentially quite negative in terms of carbon losses. And so I would caution against, let's say it was soybeans or whatever, sunflowers, going with another broadleaf and having another year of low carbon, low residue is really potentially damaging. So David, I had a lot more, but I'm gonna go ahead and just stop there and turn it over to you. And if there's other questions about specific, I didn't really get into some of the specific recropping options, but if people want to put that in the chat box, we can certainly discuss that further.
Are you going to be staying around until until we get done with the program today, Chris?
Yes, I will be.
Okay. Yeah, feel free to. I don't see any questions or comments at this point, but if you think of any question that you should ask to Chris, please feel free to type it in, and we'll both kind of get our presentations done and come to that those questions.